Welcome to a new edition of the Engineering Quick Tips.
Hello there, this is Dave, your quick tip guide for the engineering job link. Have you ever been curious about that spouting stream you see from these tugboats that are putting fires out? Did you know that in 1 minute, at 500 gallons per minute, you've transferred enough weight to be equivalent to that of your car? Part one purpose of this video series is to set up four pressure drop calculations and pump sizing for a system such as that, so that whenever you click your pump on, you will have more than a trickle at the end of your nozzle. Now this may be a simplistic example for some, but it wasn't so simplistic when those sums started. All right, and it wasn't simplistic for me in the beginning as well. So with that said, let's get started. The first thing we need to do is set up a problem statement. This is a functional design for a fire nozzle or a monitor on a vessel that will throw at least 500 gallons per minute of seawater to a distance of at least 150 feet out. Now to do that, you kind of want to do think of a few things, or to do a few things, I guess. So as an overview, you want to pick a nozzle. You need a nozzle that can handle that flow and that head. All right. Number two, you want to lay the system out generally so that you kind of know, what kind of distances we're talking about and where you're going to get things from and where you're sending them to. All right. And once you do that, then you can size the pipe system, and you can size a pump as well, and those two steps will be part two of the video series. And once you've done that, your functional design is complete. You can start putting things on a drawing. All right, we want to pick a monitor, and to do that you want to look at your operating point, and our requirement was 500 gallons per minute at 150 feet of throw. All right, and what we've picked is the Elkhart brass model CSW-L version. It's 2.5 inches in size, and it's a nominal pipe size. And then you have different flow settings on this, and this one has 500 gallons per minute. Here's that nozzle on a monitor. And this one here is a Stingray deck gun, just as an example. All right. And here are the specs. So at 500 gallon per minute setting, you get 516 gallons per minute if you supply 100 psi at the nozzle. So at 100 psi at the nozzle, you can get 173 feet of throw. That's your effective reach with no wind blowing it elsewhere. All right, once we get our nozzle selected, then we want to look at the system layout. All right, so what you want to kind of do is think of the vessel or the structure in some position that you can most easily visualize the system. And that's what we've drawn here on our little tanker. And our important PC parts are going to be the sea chest, where we'll draw seawater from. And we want to send that seawater to a monitor all the way at the front of the vessel on the pointy end. And then we need to know a distance in between, and height of installation, deck height, and then this is helpful to the vessel breadth, just for routing purposes, or general routing. So once you've got those things in mind, then you're pretty much set to size the piping system and select the pump. Now we're not going to do that in this video series. That's set for this video set one. That's on the next video. I did want to mention that I've previously done this by spreadsheet, but what I used today is a program called PipeFlow, and that's what I'll be showing you in that next video. But let's move back to the spreadsheet. I do want to at least offer you that spreadsheet for free in exchange for your watching of this video. So take a look at the video notes for a link, and follow that link, and you'll be able to download a free copy of that spreadsheet, for your records, and you can use it any way you want. This video is a service of the engineeringjoblink.com.